Assalamualaikum and hi everyone, welcome to our plane analysis program. To start off, I will introduce our group members for the group assignments too. So first of all, we have Muhammad Ali Ashraf bin Aznan with the ID number of 18002292, and next we have Wan Afwal bin Wanzaki with the ID number of 18002341, and next we have Muhammad Zulmiftah bin Zakaria, which is me, 18002356, and last but not least we have Muhammad Shakillah bin Razali with the ID number of 18002313. So all four of us are coming from mechanical engineering, and for today the presenters are going to be Muhammad Zulmiftah bin Zakaria, which is me, and last but not least is Muhammad Shakillah bin Razali. So to start off, we will first go into the introductions. Today, with engineering, the human achieved the impossible: to fly. Did you know that there are 5,000 commercial aircraft in the sky before the pandemic at any one time over the US alone? So how does this happen? It happens because of the engineering marvels that make it possible. With that, aviation was considered as the most safest mode of transportation compared to land. The engineers designed and built the aircraft based on the understanding of lift, weight, thrust, and drag. But the big question is, how does the big flying metal were navigated? To answer that questions, we need to go what have been made by the engineers. So, advanced sensor technology is so common in Airbus and Boeing aircraft that from an engineering perspective, airliners itself are becoming as much data capture platforms as they are modes of transportation. Sensors are found across wings, in engines, in passenger and cargo compartments. Practically every square centimeter of an airline is brimming with sensors that monitor everything. So with the introductions and the background of our group projects, we will go deeper into the case study. So plane data analytics has already proved a sound investment for airlines that have discovered that with the right analytical approach, data can be used to eliminate redundancies, predict routes passengers may favor, and the most important is they can improve safety. So with that, we are trying to use the same concept from data from the sensor, and we want to analyze it using our program. So the goal is to determine plane analysis based on the velocity, average velocity, fastest plane, and the slowest plane. So we will go in brief on how does radio altimeter works for our program. So for these particular sensors, we will obtain the altitude because the altimeters are designed to calculate the height of an aircraft above the surface directly below it by measuring the time taken by the wavefront to travel from the aircraft to the surface and back again. But within our program, we will convert the altitude using the United States Standard Atmosphere Air Properties or any other aerial region spaces air properties, and we could obtain the density of the air surrounding the aircraft. So after we got the densities based on the altitude from the radio altimeter, we will discuss a bit on the working principle of the pitot tube. The pitot tube consists of an L-shaped hollow tube which has two holes. The first hole is generally used to measure the stagnation pressure by taking note of the air ramp. So it's called as the ramp pot, and the hole number 2 is used to measure the static pressure of the air. So it's called as the static pot. From these two pressures and density from the previous sensors, then we can calculate the velocity using the fluid mechanics equations, which is 2 in the bracket of pressure 1 minus pressure 2 in the bracket of divided by density. So these are the working principle of the pitot tube and the radio altimeters, and we apply it into our program. Alright, to recap again, here we have the input data from the sensors. First we have the air pressure 1 or the stagnation pressure, And second, we have the aperture2 or the static pressure, the altitude, which we will be converted into density. And then we have, last but not least, the time of the flight. To make sure that the program works as intended based on the sensors and the intended analysis, we incorporated and applied the concepts from the lectures of TEB2132, which is the distribution structure. And next we have the repetition structure. And next we have array and vectors data storage. And last but not least, text file processing. And here we are, the solutions part to our problems.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Shakillah, and today I will present the flowchart for our program. Okay, if you look at this, there are 3 flowcharts. Actually, these are the main flowchart, and these 2 flowcharts are for the subprocess, which I will explain later. So, if we look closely on the main flowchart, firstly, we declare the variables that are needed for value storage and also for the calculations. And then we also declare vector, the necessary variable for vector that we need. And also we declare the data type for if string and off strings, because we are going to read the input from the text file, and also we're going to write the output into the output text file. And firstly, we read the number of planes. The number of plane here means how many planes that we are going to calculate, and we're going to enter the loop, the first loop, the outer loop, and we look at the condition if I is equal to 0 and I lesser than the number of plane, how many plane that we want to calculate. And then if yes, we enter the loop, and then we read the plane ID, and also we read the number of time interval, which means the number of time interval here, how many time interval that you want to calculate. For example, you want to calculate for 2 time interval, 3 time interval, it depends on you. And also we declare the vector for time, pressure 1, pressure 2, velocity, altitude, density. The size of the vector is according to the number of time interval. And firstly, we initialize the sum equal to 0, and then we enter the inner loop, the first inner loop, and then we look at the condition if I lesser than number of time interval that we asked from the input before. If yes, then we read the time, the pressure 1, the pressure 2, and altitude, and then we store it in the vector, the respective vector. And then we going to look for the condition of the altitude. This is the subprocess part. If we look at this subprocess refer to this flowchart. Yeah, this right flowchart here. If we're going to check the condition for each altitude, if the altitude is greater than 0 and lesser than 100, then density will be this value. And if altitude is greater than or equal to 1000 or lesser than 2000, then this will be the value for the density, and so on and so forth until it reach the last condition. And then we're going to the main flowchart again. We're going to calculate the velocity based on this formula, which is 2 times the pressure 1 minus pressure 2 divided by density. And then we also calculate the sum equal to sum plus velocity. And then we increase the I plus, and then we enter the loop again to calculate for the second time interval, to read the time for the second time interval, and also the pressure and also the altitude for the second time for the first plane. And then until the condition is false, then we're going to exit the loop, and then we calculate the average the average velocity for the plane, for the first plane, based on this formula. And then we going to put the plane ID and also the average velocity for the first plane into this vector. And then we also going to write, which means we are going to display this plane ID into the output test file. And then we enter the second inner loop based on this condition. If the condition is true, and then we going this loop is basically to just display the output on our calculation before. We're going to use the for loop to write the output based on this condition, and then we write the time, and we also write the velocity. And then it going to escape or exit the loop again, and then we're going to write the average velocity for the first plane just now. And then we going to check the condition. This is basically for the analysis of average velocity. If the average velocity for the plane just now is greater than v fastest, which is holding the value of 0, if the condition is true, then v fastest will hold that value of the average velocity, and also the plane ID just now will consider as the fastest plane, and it will store in the p fastest. If this condition is false, then we're going to check the second condition. If this condition is true, then we're going to execute this operation, and then we going to increase the I++. We're going to increase the I++ again, and we're going to enter the outer loop again for the second plane or third plane, or how many plane you input just now. And then if it reach the last plane, or the condition is false, then we're going to exit the outer loop, and then we're going to sort the average velocity and also the plane ID in the vector. This is the subprocess, and we're going to look at this flowchart. For this flowchart, this operation is to sort the average velocity and also to sort the plane ID. So for the first loop, this is the outer loop. For integer I equal to 0, I is less than number of plane just now. If yes, then we're going to enter the inner loop. For integer j is equal to the number of plane just now minus 1, and j is greater or equal to 0. If the condition is true, then we enter this inner loop, and then we're going to check the condition. If the first average velocity is lesser than the average velocity for the next one, then we're going to sort. Actually, for this operation, it is just to, if we have 3 memory location, we will just bring the lowest value to the front, and then the highest value to the back, which means to the last memory location, just to basically understand how the operation works. And then until it already sorts for the average velocity and also for the plane ID, and then we going to exit the loop. We're going to enter another loop. So this loop is just basically to write the output, just to write the plane ID and also the average velocity into the output test file. And then we escape this. We're going to enter back the main flowchart, and also lastly we just write the output for fastest plane and also for the fastest velocity, and also the slowest plane and also the slowest velocity. So that's about the flowchart of our program. So next we're going to look at the coding Alright, so before we going to look the C++ coding, I just want you guys know on how to put your input in this input test file to use our analysis program by using C++ code. Firstly, for the first line, you need to enter the number of plane. These three refer to the number of plane, how many plane you want to calculate to analysis. This is for the first plane ID. You need to enter what is the plane ID. You can write the character and also number. And also the third line, for the number of time interval for this plane, how many time interval you want, and then you're going to insert the time 1 and also pressure 1, pressure 2 and altitude at this time. And for the time 2, the same, just enter your pressure 1, pressure 2, altitude at the time 2. And then this is done for the first plane. For the next plane, second plane, you're just going to insert the plane ID for the second plane. For example, MH370, and then how many time interval, you can just write 3 or you can write 4 based on your analysis, based on your desire, and then just follow the sequence of this first plane ID. But just to let you guys know, if you are going to analysis the input from this input test file, these words is not necessary. What I wrote here just to let you guys know what is this line means. So basically, you just need to follow this sequence. Yeah, so that's all. So let's take a look at the C++ coding. Okay, so for the C++ code that we have done, firstly, as the flowchart mentioned before, we need to declare the variables needed. First, declare the number of plane, the integer type, and the number of time interval for each plane, and also the variable for the plane ID. And then the vector variables for the analysis later on, the vector for the analysis of the plane ID, and also the average velocity, these two lines for the vector variable for the analysis. And then we declare the variable for the fastest and slowest velocity, and also the plane ID, these lines, v fastest and v slowest, and string p fastest, p slowest. And also we declare the variable for the sum and average for the calculation. And we also declare the variables to sort the planes according to average speed. So these are the variables that we hold the value. So average, sort name, and we also declare the variable for in-file and out-file. In-file if stream data type, and out-file of stream data type, because we are going to read the input for the input test file, and also we are going to write the output into the output test file. So this part, these two lines 34 and 35, just to open the location of the input test file and also the location of output test file. And this line just for the cosmetic part. So, and also this line number 76, and also the line number 77, this is just for to display the current date and the current time of your program analysis, which I will show you on later on the output test file. And the first program starts by reading the input test file. For the first, we are going to read the number of total plane from the input test file, and then we are going to enter the first loop, the outermost loop, for integer I equal to 0 and I is less than the number of total plane. Total plane is the number of plane that you want to calculate to analyze. and then we are going to read the plane ID, the first plane ID, and we also going to read the number of time interval for the plane, and we declare the vector variable for time, pressure 1, pressure 2, velocity, altitude and density, which holds the size of time interval. Based on the time interval, these are the size for the vectors, and we initialize the sum equal to 0. This is the function of this code is to reset the sum value for the second plane or third plane, and so on and so forth. And we're going to enter the second loop for integer I equal to 0 and I is less than ICT. ICT means less than the interval count, how many number of interval. And we are going to read for the time 1, pressure 1, pressure 2, and also the altitude for the first time interval. The time will be in the 24-hour system, so you need to write it according to 24-hour systems. And this pressure 1 and pressure 2 is in Pascal. And altitude, the altitude is in the unit of meter. The reason we need the altitude is to determine the air density. And then we check the condition for the altitude. If the altitude is satisfied for this condition, then the density will be this value, and we based on this condition we are going to determine the density. And if we are done with the checking of the condition for altitude, we are going to calculate the velocity, the velocity for the plane, the velocity for the first time interval. We are going to calculate the velocity based on this fluid mechanics formula, under the Bernoulli. Based on this formula, V equal to 2 times pressure 2 minus pressure 1 divided by density, and then we times with the 1.943384, because this we are going to convert in the units of knots. Because if you calculate using this formula, we are going to get in terms of meter per second, but we are going to convert to into the units of knots, which are suitable for the plane. And then we calculate the sum equal to sum plus velocity, and then we going to exit the inner loop, this first inner loop, and then we are going to calculate. But before that, before we going to exit this inner loop, just now we just calculate for the first time interval, and then we going to repeat this step for the second time interval until the last time interval, and then only we going to exit this loop. And then after we are done, we are going to exit this loop. We are going to calculate the average velocity based on this formula. We are going to calculate average velocity equal to sum divided by the number of time interval for the first plane, the average velocity for the first plane. And then we are going to insert the first plane ID and also the average velocity for the first plane into these two vector. We are going to store the plane ID and also the average speed into these vector variables for the analysis part. And then we going to write the plane ID into the text file. This line number 144 is to write the output for the plane ID. And then we going to enter another loop, the inner loop. For integer I equal to 0, I is less than the number of time interval. Basically, this loop is just to display the time of flight and also the velocity at that time. We are going to display the output by using the for loop. And then we also going to write the output for the average velocity of the first plane just now in the units of knots, and then we analyze for the fastest plane and also the slowest plane. For the, we're going to check the condition if the average velocity in the vector just now, the value of average velocity in the vector just now is greater than v fastest. This v fastest holding the value of 0 just now as we declare. V fastest is equal to 0, v slowest is equal to the maximum number of the velocity. And if this condition is true, then the average velocity just now will be installed into the v fastest variable. And also according to that means if the average velocity for that plane is fastest velocity, that means the first plane ID just now will be the fastest plane. So we're going to install the plane ID just now into the p fastest, which means the fastest plane. If this condition is not true, if the condition is false, then we're going to check for the second condition. If the average velocity is lower than v slowest, that means the v slowest equal to that average velocity, and also that plane will be the slowest plane. So after we are done with this code, with this operation, we are going to execute the I++. We are going to increase the I++ and then we're going to enter the loop, this outer loop again, to analyze for the second plane or third plane and so on and so forth. After we are done with all the plane, we are going to enter another loop for the operation of sorting the plane according to increasing average velocity. For this operation, we are going to use a for loop. This lines is just basically means that we, for example, just to simplify on how you can understand this. For example, if we have 3 memory location for the vector, we are going to bring the lowest value into the front, which means the lowest value will be in the first memory location, and then we are going to keep bringing the slowest into the front, and then finally the highest value will be in the last memory location, in the back of memory location. So that's how we sort according to increasing average speed. So after we are done with the sorting part, we are going to use another for loop to just basically write the output of the plane ID and also the average velocity for that plane. We are going just to display it inside the output test file, and then we are also finally going to write the output of the fastest plane, this 2 line, just to write which one is the fastest plane with the fastest velocity, and we are going to write the slowest plane with the slowest velocity. And then finally all the output will be in the output test file, and then we just done with our analysis. Alright, so this is how the program will looks like. It says here this will calculate the average speed based on these 3 parameters. We just need to click enter. But before that, actually we are getting the input from this input test file. So now you just need to click enter, and then it says here calculation done, data can be viewed in the output test file. Successfully write the output file on Friday, March 26. These are the current date and these are the current time that you are doing the analysis. So now let's look at the output test file. So these are the output test file. It displays the first plane ID, second plane ID, third plane ID, and the time flight for the time flight, the velocity, and the also average velocity for each plane. So these are the results, these are the values that we are done. And we also have sorted the plane ID according to the average speed, increasing average speed. So these are the results, increasing speeds with the plane ID. And we also determine the fastest plane and also the slowest plane, which the fastest plane is MH370 with the speed of this, and the slowest plane is this with the speed of this. And it also display the data stored in file on the current date and also the current time. So I think that's all from our group. Hope you guys can learn something from our presentation.